Okay, so from the beginning we're going to be talking about the arrays today. So tonight we're going to go over the first two sections, introduction to arrays and arrays in functions. So we talked about so we're talking about arrays to be a list that's going to have things in there. So it's going to be a list of names, list of temperature, list of numbers. So the question was, if we have 5 test scores, we're going to create 5 variable for it. What's going to happen if we have 100 or 1000 scores in the memory? How we're going to save those things and how we're going to name them. So if I say score 5, that means I'm creating a list of 5 scores, right? So if I have a list of 5 scores, that means I'm going to start with index 0. So this is going to be 0, 1, 2. So it's going to be 0, 1, 2, 3, and 4. So I can put my scores in there. So if I have a score of 70, 80, let's say 75, 85, and 90. So when I reference these things, I'm going to say a score, and I put it in the bracket. So a score 0 is going to be what? 70. A score 1 is going to be 80. And what we have to worry about is a score 5. Even though when we create it, we call it int a score 5, which created 5 scores, I cannot reference a score 5 because it's going to go outside of my array. Okay, so the score 5 is not going to be a correct number that I'm expecting in my array. That's something that we have to work on for this chapter, that the indices starts from 0 and going up to 1 less than the size of our list. Yes, sir. No, it does not. Okay, the question is if it's going to put it in order. We're gonna learn how to insert it. So all it knows is it knows its index. So whatever index I put, it's going to put it in that index. It does not automatically put it in there. So I have to say a score 0 equals 70. That's going to put the 70 in the score 0. Next, if I say a score, let's say a score 2 equal 75, it's going to put 75 in the score 2. So we're going to be learning how to do these things. The most efficient way for the arrays is a for loop, and we're going to learn how to use the for loop to do these things because it's going to have a starting and ending point. Any other questions on this? Yes, sir. Right, we define a score as what? Integer, right? Right here, int. Okay, that means all the scores are going to be the type int. So when we define it as a data type, you can use anything you want. So if I change this int, so we put it what? We put int, if I can get this working. So we put int a score 5. That means I'm going to create a list of integer of 5. They're all integer. So if I put char score 10, I'm going to create what? 10 of characters. I can put a string, I can put double, I can put anything I want in there, right? any data type. So that's what's going to create the list. Any other questions? Okay, so we can put a variable as a index, meaning that if I want a reference to 10, I can use a variable that's equal to 10 and use that one. Are you guys okay with that? This is not important for you guys? So we can use a variable instead of the number. Okay, when we're referring to one of the indexes, the variable, we can put it inside the brackets to say, you know, what we're going to have. So the numbers that we can use is from 0 to the size minus 1. So size is going to be the size of what I'm using for creating my array, and always going to be minus 1. So if I have an array of 5, I can go from 0 to 4. So in this case, I'm using n equal 2, and I can use it inside the bracket n plus 1. Remember, this has to be integer. It cannot be double, it cannot be anything else. It has to be integer only. So n plus 1 is going to be what? 3. So I'm going to put in the index 3, 99. Index 3 is what number? So if I start with the 0, 1, 2, 3, and 4, number 3 is going to be the 1, 2, 3, fourth element. Okay, so it's always going to start with 0, and that's something that we have to practice for this chapter. So number 3 is actually, the index 3 is element number 4 in the array. So because if we are starting with the 0, next one is 1, 2, 3 is the element number 4. So if I want to reference the fourth element, that's going to be index 3. So the best way to do any kind of a work with the array is a for loop. The reason for a for loop, because we have the beginning and the end, and we always start with the 0 and we go less than the size. So it's a size minus 1. So we define 5 as the size of this array, and then we're going to define size minus 1, which is going to be less to 4. So we're going to go 0 to 4. Now we're doing the cout score I. So every time we go through this loop, the first time is going to be 0, then it's going to be 1, 2, 3, 4. What is the score of 5? We cannot go there, right? So it's just saying max minus a score I. Once again, it's going to take that score. The first time is going to be the element in the 0, then 1, then 2, and it's going to take the max and it's going to subtract that one from it. So every time we want to use a value in the array, we're going to reference it with the bracket. And the for loop is going to just go a step through it to go through all of them. So in this display 7.1, with the way that we define it is, now we have int I, a score 5, and the max. So what's going to happen if I reference a score 6? It's actually going to go and modify this max, because the max is right after the score. So we have the score 0 to 4 in here, and then it's going to go over the next one, whatever is in the memory. So to do this correctly, we're going to start here. We're going to take the very first one, a score 0. We're reading it from the user, cin a score 0. So whatever user puts, I'm going to put it in the first element. I'm going to set my max to the first element. Now I'm going to go through this loop because I already used my first element. I'm going to start with the second element, which is index 1. I'm going to go from 1 to less than 5. I'm going to read the score into my array starting with 1. So the first time this is going to be 1. I'm reading it into that. And then I'm checking it to see if the max is, if this number is greater than max, I'm going to set the max to this number. So this is the way I'm going to create or find the maximum number of this 5 number while I'm reading it into the array. So another for loop here, that's 0 to 5 to less than 5, that's 0 to 4. We're going to go into that and we're going to print it. Why don't I have a braces over here and I have braces over here? Why don't I have a braces in this for loop and I have braces in this for loop? Yeah, it's one statement, you don't need a brace it. Okay, this is my favorite way of doing it. I set the size of an array to a constant. So in this case, it's calling it the number of students. The reason that I like to do this is because I can use this constant not only to create my array, I can use this one in all the for loops related to this array and even passing it into the function. So now if 50 doesn't work for me anymore and I want to change it to 100, I don't have to go through all the codes and changing it to 100. I just come in one place and change it to 100. Everything else is going to get done. So you can see that I'm using that one to create my list, and you can see that it's going to be used in my for loop. So if I change this to 100, automatically I'm going to create 100 scores, and I'm going to go from 0 to 99. You okay with that? Well, you can, but the problem is because the C++ does not check where the boundaries are for the array. If you use a while loop, you can potentially go out of the boundary. So a very good loop for the arrays are for loop. That doesn't say that you cannot use while loop, but the for loop is much more secure, and we are sure that's not going to go out of bound. You know it's going to be recording and it's going to be in the Blackboard, right? Okay, no problem. So the most compiler does not allow you to get the size of your list and the runtime. So you have to know before your program starts running to know how many number of elements you need in your list. That's one of the drawbacks for the array. So no matter what number you put in there, you can either have too much or too little. So I'm going to thinking about I'm going to have so many students, and if my students grow more than that number, then I have to go back and change that number. So I cannot change the size of the array asking for a number. Most of the compiler are not going to let you do that. So the way we're going to declare it, we're going to have the type name, array name, declared size. So we can have any types over here, character, char, double, integer, anything we can have it here, and then we can have the type, and then we can have the size. Yes, sir. Go back one. Say what again? No, the reason that it cannot do this is we have to define this before we start running the program. Because we are running the program and we're asking the number and we try to create the array after we're running the program. That's the reason it doesn't let you do it. Yes, so if I have n equal 50, then I can do int size, what do you call it, the score n. Now there's nothing wrong with this, but when we're running the program, we cannot go and read n from the user and then do this. So this is the problem, because it's reading from the user.
How about I set the n is equal to 0, and then after that I say cint n, and then
No, it's not going to work. No, it has to know the size before you. When you're compiling a program, it has to know the size of your array. So when during the compilation, it needs to know the size of the array. And once again, it says most of the compilers. So try it out. Let me know if it works for your compiler. So the way it's going to happen in the memory, just going to be a continuous things in the memory, and it wants to create it before it's running the program. So we have the numbers that's going to be stored in bytes in the memory, and what we're going to do in a memory. So if I have my memory set up, and I'm going to be using a certain section of the memory for my program, it's going to have a piece of that section for its variable, and it's going to keep it in there. You guys use at the beginning of the course when you were working with the assembly and binary on the other book, it was giving you the data. So my data is going to be set up over here. So int is what? Int is the size of the word for the computer. So it can be 16, 32, or 64, depending on what size. So when I say int, and a variable is going to go in there and it's going to assign out. So when it gets to the array, it's going to basically pick up that many of the integer or char, and it's going to assign it to the array. So if you look at it, the memory as a byte, the addresses in the bytes, that's the way it's going to be setting it up. So we have a simple variable is stored in consecutive bytes. The number of bytes depend on the variable type. So you guys did some exercises in the other book on this. So if we say we're going to create an array of 6, that means we're going to get what? Integer, whatever size the integer we have, we're going to multiply it by 6, and that's the space that we need for this array. The reason it's going to need the 0 is going to be pointing to the beginning of this, whatever is created. That's going to be my 0, and then it's going to add to it to find the address of the next one. So how is it going to find out number 3? It's going to multiply 3 by the size of the int, and then it's going to add to the beginning of this address. So if you're looking at the memory like this as a byte, and we're thinking about the int in this system being 16, means 2 byte, the A0 is going to be 2 of these things, and then A1 is going to be the next 2. So the address of A0 is right here, and the way we're going to find the number 3 is what? We're going to find these 2 bytes, multiply by 3, and then we're going to start with this address. So we're going to go down 6, and we're going to pick it up. Now, what I was talking about earlier is, even though my array finishes over here, the C++ doesn't care or doesn't know where does it end. So if I go to A6 by accident, I'm basically going to go to the next area. It's going to pick up things in there, it's going to write to that, So in the previous program we had a max, so even though max has not been modified, I can potentially write to max or read the max into the A6 or A7. So we got to be very careful not to do that. So we do not have the out of range in the C++. The Java is the one trying to figure that out. So in this case we have int A6. We're creating 6 element of integer, and then we have I equals 7. So what's going to happen here? AI equal 238. It's going to go to A7, even though I don't have A7 here, and it's going to put this one over there. So whatever is in A7, which is at that address, is going to insert that one. It's not going to complain about it. So those are the things that we have to be careful. Now, how to initialize our array? One way of initializing array is through braces. So if I have a small size of array, I can just put the numbers like that. Of course, if I have 1,000 of them, I cannot do it like this. So the braces, I can put the numbers with the separation of the comma. So I have 2, 12, 1. So children 0 is going to be what? 2, and then 1 is going to be 12, and 2 is going to be 1. So if I have 10 elements, and if I put just 2 numbers in there, it's going to pick up those 2 for the first 2, and then it's going to set the rest of them to 0. So how do I put all of them to 0? How do I make the int A 10 and I want to set all of them to 0? Pardon me? Good. So if I have just one single braces and put a 0 in there, the first one is going to be 0 and the rest of them are going to be 0. So I just need the braces of a 1, 0. So if no values are listed in the array declaration, some compiler will initialize this variable to 0. We cannot depend on this. A lot of places they are not doing that. So we want to put it 0 in there to be sure the 0 is going to work. So can we do this? What's the difference between A4 and int A5? Remember, these are the ones going to be in the test. What's the difference between this one and int A5? No answer? No tries? Okay, next section is going to be talking about how we're going to use arrays in functions. So if we set up the array as A10, that's going to be creating 10 elements of A. That means the index is 0 to 9. We're going to have a function. The way we're going to call that array, we're going to put the name of the array. We don't have a bracket in it. So we can send it as a parameter. We don't call it as a call by value, meaning that if I have a list of 1,000 elements, I'm not passing 1,000 elements to the parameter. I'm just sending the address of the beginning of the array. I'm not sending the whole array, I'm just sending the beginning address of the array. For that reason, I always have to send the size because I don't know what size is the array inside the function. So I'm going to have an array and I'm going to have the size of array. So the way we declare it is going to be name of the array, name of the function. We're going to put the int and we put the name of an array with the empty bracket, nothing in it, and of course the size. The way we're going to call it inside the main or somewhere else, the way we're going to call it is we're just going to put the name of the array. We don't need the bracket, we don't need anything else. So we just put the name of the array and that's the way we're going to call it. So we declare it, we call it, and let's look at the definition. So that means because we're sending the array and that's just the address of it, that means anything that happens to that array inside the function is going to actually modify the actual array. Remember, that's a memory cell. So any changes to array, it can change the array. So if I have elements in the array, the calling function can change things in there. So we can call it in like a score and 5, time and 10. So those are the different arrays and the different sizes. So we should send the size in for the program to know what the size of my array is. Now if I don't want to change the stuff in my array, I'm going to use the const. So if I use const here, that means my array cannot be changed inside the method. So if I or anybody else goes into that method and try to modify the content of my array, then it's going to get a compiler error. So the const is going to force it not to be changeable inside this function. So if I have an array, I want to protect it, I don't want to change it inside the array, I put the word const in front of it. We have to use it in the declaration and we have to use it in the definition. So now if we have another function calling another one inside, that the one has a constant, the other one doesn't have it, the one that has a const cannot be changed. So here we have a const, we cannot change this one. So some people they look at these things and say, oh, this is a good one. What about if I want to return an array? This is one of those seldom things in C++ that you say you cannot do that. We can do things later on, basically returning the address. But array, remember, we don't play with the array itself. We're working with the address of array, so we can send the address of array later on. You'll learn how to do it. Right now you cannot return an array. So this case study is talking about the production graph, and the key here is when you want to write a program, you have to do the design first. You have to come up with the algorithm of how to do it and break it down to smaller pieces so you know which functions you're going to be writing and focusing on each function. You will put the subtasks as functions. So in this case you have the read input for the input data, the scale and graph for the output bar. So remember that every time you're writing the code in your function declaration, you have to put the comments on it. So we are defining number of plants as a constant. The reason that I know it's a constant is because it's all uppercase. I was looking at some programs. Some students like to use all caps all the time. The convention is when it's all caps means is constant. So it's defined over here, const int number of plants 4. So anywhere in this program I'm going to use number of plants is going to be 4. My main is going to be a small. I cannot have a large main anymore. My main, all it does is calling other functions. So we have the input for the plant numbers, and then set the production for plant -1 to the total. So we're using the loop again, 1 to last plant number, whatever it was, so we know what it is. Every time we write a function, we want to have some kind of a test program to test it, and also we want to have some testing for each module or each method. So for that we have to know the range, we have to know what can go wrong, and we can test those things out. So in this case, if we are reading some stuff into our function of the input data, we're just going to create a loop to print them out or look at them to be sure we're getting everything done correctly. Remember, we are going to be testing each function by itself. So if I have get total, I want to be sure that that get total is going to done correctly, and I want to print it out. So I can test each module by itself to be sure it's going to be correct before I worry about the other modules. I'm going to be focusing on each module or method by itself. So it's calling the function. Remember, we are not going to be using the bracket for the calling it. We just use the name of the function. So this is the definition of the function. So the question here is, why are we using 1000.0 instead of 1000? Right, so we're going to have some decimal, so we're going to make this one, because remember these were all integers. Integer divided by integer would lose the decimal point. So it puts in here, so we're going to have some fraction, then we're going to round it. Round means what? 5 and above is going to go to the next number up, less than 5 is going to go down. There is another function called floor that's going to basically lose the decimal point. So floor of 3.4 is going to give you 3. Floor of 3.9 is going to give you 3. What is the round of 3.4? 3. Round of 3.9? 4. This is another way of doing this. You can add 0.5 to it. So if it's more than 0.5, it's going to return 4. So I can use this function to do the round for me. Just adding 0.5 to the number and then float it. I can force this to be integer. That would do the same thing too, right? It's going to. So basically, if I force this to be integer, it's going to lose the decimal point. So it would do the same concept. So every time we write something, we're going to be doing the testing on it. So we're writing a test function or a test program to test the last function. Once again, we are declaring our functions with the comments. So we have to put the comments on top of that. And then we're going to do the graph, and we're going to test the graph by itself. And it's going to be doing. You better get on it. Alright, so that's what I have for these two sections, and I covered the other two sections on Monday. To be sure, we're gonna. I set up all the assignments through the end of the semester, so you have all the assignments, and your final test is going to be on Monday 11, June 11. Any questions on this? Okie doke.